A lamp has two light bulbs with an average lifespan of 1,500 hours each. Assuming we can model the probability of failure of these bulbs by an exponential density function with a mean of 1,500, find the probability that both of the lamp's bulbs fail within 600 hours. So if we let x be equal to the number of hours until the first light bulb fails, and y equal the number of hours until the second light bulb fails, we want to find the probability that x is less than 600 and y is less than 600. If we take a look at our notes below, this probability is equal to the double integral over the region R of f of x comma y, where f of x comma y is equal to the product of f of x sub 1 and f of y sub 1, where both of these are the exponential density function shown here, where in our case, mu, or the mean, is equal to 1,500. So again, f of x comma y is going to be equal to f of x sub 1 times f of y sub 1, where f of x sub 1 is going to be 1 divided by 1,500 times e raised to the power of negative x divided by the mean of 1,500 times f of y sub 1, which is now a function of y, so we have 1,500 times e raised to the power of negative y divided by 1,500. Multiplying the coefficients, we have f of x comma y equals 1 divided by 2,250,000 e raised to the power of negative x divided by 1,500 e raised to the power of negative y divided by 1,500. So this is going to be f of x comma y, and because we're looking for where x is less than 600 and y is less than 600, the region R is going to be this square region in the xy plane. So now we know the probability of x being less than 600 and y being less than 600 is going to be equal to, again, this double integral, where f of x comma y is this function here. So let's write this as 1 over 2,250,000 times the double integral of e to the negative x divided by 1,500 times e to the negative y divided by 1,500. Now for differential a, because our region is square, the order of integration doesn't really matter. Differential a is equal to, let's say, dx dy. And now for the limits of integration for x, because our region is square, we're going to integrate from 0 to 600. And the limits of integration for y are going to be the same from 0 to 600. Now let's go and evaluate this on the next slide. We first integrate with respect to x. Notice how we'll perform u substitution, where u is equal to negative x divided by 1,500. So differential u is equal to negative 1 over 1,500 dx. So if we multiply both sides by negative 1,500, we have negative 1,500 differential u is equal to differential x, or dx. So we can think of e raised to the power of negative x divided by 1,500 differential x as negative 1,500 e to the u du. So that would give us negative 1,500 divided by 2,250,000 times the integral from 0 to 600 of, the antiderivative is going to be e to the u, which is really e to the negative x divided by 1,500, and we're treating y as a constant. And this fraction simplifies to negative 1 over 1,500. So these are limits of integration for x, so we would have e to the negative y divided by 1,500 times, when x is 600, we'll have e to the negative 600 divided by 1,500, and when x is 0, we just have e to the 0. This simplifies to e to the negative 2/5 minus 1, which are both constants. So let's write this as negative 1 over 1,500 times the quantity e to the negative 2/5 minus 1. Then we still have times the integral from 0 to 600 of e to the negative y divided by 1,500, and we have differential y. So now when you get respect to y, which also requires u substitution, we already use u, let's use v. So v is equal to negative y divided by 1,500. So differential v is equal to negative 1 over 1,500 differential y. Multiplying both sides again by negative 1,500, we have negative 1,500 differential v equals differential y. So notice how we integrate, we have another factor of negative 1,500. So we'd have negative 1 over 1,500 times the quantity e to the negative 2/5 minus 1. Then we have our extra factor of negative 1,500. And the antiderivative is going to be e to the u, which is really just e to the negative y divided by 1,500, which is really just negative y. And the antiderivative is e to the v, or e to the negative y, divided by 1,500. Notice how this simplifies to 1. So we have e to the negative 2/5 minus 1 times, again, when y is equal to negative 600, we have e to the negative 600 divided by 1,500, minus, when y is 0, we just have e to the 0. So notice how these two factors are going to be the same. This comes out to the quantity e raised to the power of negative 2/5 minus 1 squared, which is the probability that we're looking for. Again, the probability that x is less than 600 and y is less than 600 is equal to the quantity e raised to the power of negative 2/5 minus 1 squared. Let's convert this to a decimal using the calculator. We have open parenthesis, second natural log brings up e, power of negative 2 divided by 5, right arrow, minus 1, close parenthesis, and then squared, enter. So we get approximately 0.1087, which as a percentage would be approximately 10.87%. So again, this is the probability that both light bulbs will fail within 600 hours. I hope you found this helpful.